Hi, Max. How are you? Let's go over this. Question number one, you have an issue here with this area. It should be 3 squared minus a quarter of pi 3 squared. If you look here, this over here, like this quarter circle, the radius is 3. I don't know how you got 5 from. Okay, otherwise it's good. Part B was good. Part C, well, in the end, your final answer was fine. I just want to make you aware of something. You don't have to try g of -2 because if you look at your sign here, right? So g, this is the correct sign analysis, or g prime. So you have to consider -1. But if g prime out of the gate is positive, that means at -2, right? There's going to be a min. There's no need to test it. I mean, it's fine that you did, but you just don't need to. Okay. Very good. And then your second page. Let me get there. Your second page. Why can't I find the rest of your? What's going on with your? Okay, here it is. Is this you, Max? Let me see. Yes. Okay. So the second page here, all this is good. Perfect. Very good. Very good. So a couple things. When you went from the Taylor for, this is D is fine, E is fine. The Taylor for H of X is the antiderivative of f of X. So you took F's derivative. You want to take its antiderivative. What I mean by that is, come over here. Let me show you. Okay. So if you see, right, if you look at this, you're told that h of x equals this, right? And that means h prime of x equals f of x. And if f of x is here and h equals f, to get to h, you're going to anti-differentiate f. So that's here, okay? And then you plug in 1 into that. So take your time, okay? And just read. I mean, this whole differentiating a Taylor and integrating a Taylor, I absolutely believe that it's going to show up. We've just seen so many examples of that. Your second question here, or rather this one, the definite integral, this definite integral here should be, this denominator should also be -p, not -p minus 1. Okay, it should be just -p, which throws us all off. All right. Okay, pick it up. Let's look at the rest of this over here. Question number 2. Very good. Question number 2, and you have just a positive value. Good. Question number B, you are doing, yes, very good. Partial fractions. Very good. You caught the absolute value. Excellent. And then part C is one that I think probably caught a lot of people. Part C, it is an improper integral, actually. So if you look at this, and this is the fact that you're out of time, again, not a big deal, because most people would have been. But let me bring you over here as to how to do it. So part C right here. So this is part C right here, if you follow me. Okay. So this is it. And what happens is I just kind of wrote it like I factored the denominator, right? And I noticed that 1 is a point of discontinuity, and that value of 1 is on this interval of integration. And when that happens, you have to split the integral into 2 improper integrals and then write them as 2 limits of definite integrals added. And when this happens, it's really important to recognize that when you have to do a split of an improper and get 2 improper, if one of the impropers diverges, like I just did the left one, if one of the impropers diverges, it really doesn't matter what happens over here. The whole thing is going to diverge, okay? But Max, this is, let me take a look and let me give you a sense of what your score would be. I think, what was this page again? Let me do a little bit of recap. Good. Yeah, that. Yep. You're right between, I'd say you're right at a 5. Like you're right on that border, which is outstanding. I mean, 4 or 5 of this test is outstanding. So just FYI, great job, Max.